At the end of the last video, I mentioned that I picked up a Breakout arcade cabinet. Let's get this out and take a tour. Some plywood, but mostly made from particle board. Heavy SOB. Not in great shape, but nearly 50 years old. Someone added an external coin button. There's just a single speaker here. The large white buttons are for single player or two-player start. Serve button on the right and paddle controls in the middle. Back cover was off. Need to fix the latch. Here's the cabinet label. Here's the board and RF cage. And the monitor. Transformer and wiring harness. Fuse and filter are exposed. There's a bunch of stuff in the bottom. We'll get it out and take a look. The cabinet is assembled with staples. I'll cut some and use screws. That'll allow us to remove this panel for easier access. I don't think they used any glue here. Let's pull this board and see what revision we have. The heat sink hits the cage lip, so we need to bend the board a bit to get it out. Card guides inside the cage are made of plywood. And we have a revision E board. Actually looks pretty clean. Serial number is 7069. Still pretty crispy. Looks like someone replaced the rectifiers at one point. Wow, yeah, she's pretty toasty. I pulled the flotsam from the bottom of the cabinet. There was a service bulletin with 3 potential fixes and a spare parts list. I'll scan these two and drop them in GitHub. There was also a monitor setup procedure and schematic, but for some other monitor. There was a spare 5K paddle potentiometer. There was a new latch and set of keys. This is the old one. And the coin counter. The counter was removed at some point, but has over 25,000 hits. So I've got the board on the bench. I noticed this date stamp, February 8th, 1977. You can see one repair here. That's Fox 1, the 9316 clock counter. I'll call this one KFC, extra crispy. I took out the rectifiers already. I tried to take off this cap, but they glued it down. I'll use a heat gun to soften it up. For the regulator, they soldered the screws to the board, so this should be fun. I've got that regulator and heatsink out, cleaned it up a bit. Already put in 3 amp rectifiers and a new cap. Later on, we'll put in this PSU 5. I'm using this connector to jumper to a composite LCD monitor. I'll tap the video here, and I tacked a 0.1 mic ceramic onto the audio bus before the amplifier. I also noticed that the amplifier supply electrolytic is ready to let out the magic smoke, so we'll change that out. For power, we're going to temporarily use this 6 amp switching brick. We'll just jumper it across the 5 volt supply cap. Let's plug this in and see if it smokes. Check the voltage in a few places. .75. Close enough for government work. Let me get out my digital thermal checker. Those 7483s run a little warm. Nothing's on fire. Let's see if she lights up. I got it plugged into the side inputs. The seller said that the screen just had lines running across it. This matches that. Looks like the top boundary, bricks, and paddle are there. All things driven by horizontal signals. What we don't see are the left and right boundary lines. I think we've got some vertical counter issues. But we've evidently got enough good stuff to generate a sync. Let's really quickly look at the left and right boundary signals. Nothing. Let's take a quick check of the horizontal counters at Mary 1 and King 1 first. Those are all there. And the vertical counters in Nancy 1 and Mary 1. These are running faster than expected. And no pulses on the lower vertical counter in Mary 1. Now we've got good clock. And the enable lines are changing. Let's replace Mary 1 and see if it helps. Could be bad downstream receivers, but it's typically the signal driver. I replaced Mary 1 and still no worky. Same behavior. I removed one of the downstream chips, the 7483 and Mary 2. Didn't help. But then I noticed that the Nancy 1 counter was still rolling, even with one of the enable inputs low. Both of these signals must be high to enable counting. Let's replace her. And finally, we've got some vertical structures on the screen. That's good. And the counters look nominal. We need to put back that 7483. I actually have some, but I'm just going to jumper it out. Only required for cocktail tables. Just connect the 3 used inputs to the outputs. That's a bit better, but not quite right. We've got separation in the bricks, so more vertical stuff is okay. Dumbass. I jumpered 1 to 14 instead of 1 to 15. Fix that. That looks a lot better. Still off a bit, so something's still not right. Moron. That adder feeds the next one. Need to tie that input to ground. Should have just replaced the chip. Perfect. Let's hork up some inputs and see if she works. Let's see what we need. We'll need a serve button. We'll need a paddle potentiometer. No, this one. We'll need at least one coin switch. And we'll need one of the start game signals. So I just jumpered everything, kinda dicey but temporary. Let's plug it in and try that. I'm actually just gonna scope the 1 or 2 credit line here. This'll tell us if we've dropped a coin. So yes, we have a coin, so we should be able to start a game. Let's inject a start game signal. Don't try this at home. Excellent. Ready to serve. Now we can try the paddle. Cool. Kinda stiff. Too much loose stuff here. Let's try to serve a ball. Excellent. It's not supposed to do that. Either I've got some horked controls here or we have more logic issues. We'll put this back in the cabinet and see. Forgot to try out the sound. Clip on our audio. Coin, start, serve. Sound is working. The Motorola monitor in the cabinet actually has an audio amplifier built in. They could have used that instead of using the LM380 on board. One thing that bothers me is the burn on connector pins 2 and Baker. I can't see how they even make contact. If you look at the schematic, these pins are for the power supply ground. But if you look at the wiring harness, only one pin's used. I understand the desire to separate this from digital ground, but they all tie together at some point, and this is a weak spot. I'm going to tie pins Able, Baker 1 and 2 together on the board and the harness. This will at least make me feel better. I just soldered in this PSU5. Never used one before. I don't have a 16-volt center tap transformer. Don't need one. We can just inject 12 volts DC here. And we've got a good 5 volts. Super low ripple. That can't be right. I'll scope it out later. She's a tiny bit warm, but wow, nice. And you can adjust it here. I'll do that later. This is one upgrade I recommend. And everything is still working, so let's get this back into the cabinet. Interesting that the RF cage is not even hooked to ground anywhere. And it doesn't ground to the board edge either because the board guides are wood. I'm assuming it's an RF cage, perhaps it's just for safety. Well, they do talk about an RF board in the dock, and they call this an enclosure. I think the RF board they mention is an optional interposer between the game board and harness connector, and seals the cage. But we don't have it here. We'll put this back in and light her up. We should watch the voltage as well. Plugging her in. Voltage looks good. First time firing up the monitor. Probably can't see it, but the filament's lit. Looks like it's working. Monitor needs some adjustment. Let's drop some coins. Both single and dual player buttons light. And press serve. Same behavior as on the bench, so we'll need to do a little more work offline. Well, I think that's enough for today. In the next video, we'll start breadboarding. Thanks for watching.